We're in Chicago at the Inside 3D Printing Conference and Expo, and I'm here with Hod Lipson, and he's from Cornell University, and he just finished a presentation he did on the future of 3D printing, and I'd like you to kind of hit some of the highlights on that. But first, who are you? You're from Cornell, and how do you relate to this industry, and then where is the industry going?
So I work at Cornell University. I teach dynamics and control. And actually, I'm interested in robotics. So a lot of work in 3D printing stems out of the need to explore new kinds of morphologies and understand, the interaction between control algorithms and morphology, different shapes, and what that offers for robotics.
So when you get into robotics, that's a thing that we deal with on control engineering all the time. The ability to control motion and to make things move exactly as you want them to, very precisely, and that's obviously a part and parcel of 3D printing.
Well, so most of I think the opportunity here, usually when we think about control engineering, we think about a fixed system and then we can do anything we want in software, but the mechanical system is usually pretty rigid. It's composed of standard components. We don't have a lot of flexibility as to the morphology and the structure, the shape. With 3D printing, we can now have as much freedom in the shape of the robot or the machine as we have with the software that controls it. So it sort of levels the playing field between the control algorithms and the mechanical design. It opens up possibilities and we can do a lot more things, but there's also new kinds of challenges and new opportunities for moving forward.
So 3D printing obviously involves the robotics. It also involves a lot about materials technology. And where do you see the biggest advances being made in the next few years?
So right now, 3D printing is at the stage where we can basically print any shape we want. Any shape you can describe algorithmically, you can fabricate. And that's a big departure from most of the history of engineering where it was difficult to make complex shapes and it took a lot of skill. But that is only just the beginning. From there, we are now being able to fabricate new kinds of materials by combining existing materials in new ways, by shaping them at the micro scale to create new kinds of material properties. These, on one hand, make it very difficult to predict and control, but also allow us to fabricate complex things, not unlike biology, that have very sophisticated behavior and give us new opportunity. Beyond that, we're beginning to see the ability to fabricate active systems, for example, wires, sensors, and actuators integrated into the 3D printer itself, integrated into the part being 3D printed. So we can basically embed sensors and actuators and wires. And again, that gives a lot of new opportunities for sensing, for control, for taking advantage of shape in new ways. I think the last step, which is sort of beginning to happen now, but it's really in the 20, 30 year time span, is moving from printing in continuous materials to actually embedding electronic circuits and actuators and sensors as building blocks inside the 3D printed part and really basically merging 3D printing and electronics and all of that into a complete control over matter. So we'll be able to fabricate things like a cell phone or a complete working robot.
So kind of an integration of 3D printing and MEMS technology.
That's right, MEMS and also conventional microelectronics where we can actually print things at that scale.
So are we all going to have one of these at our homes in a few years, or is that a little bit overblown at this point?
I think it's a little bit like asking in the 70s whether or not we'll have computers in our home. And the answer is we have some computers in our pocket, some at home, some at work, and some in the cloud. Same thing will happen here. We'll have some printers at home for certain things, some printers at work, let's say for printing metal in a car mechanic shop or bioprinting in a hospital, and we'll have printers in the cloud for printing other things that are not that we don't need immediately. But at home, I think we will have printers. There will be mostly for making things like toys, printers for education, and printers for food.
So we're already getting to the point where you have cloud printers, the actual machine somewhere in a centralized location, and you just send the information there?
That's right. There's all of these different scales of printers already are in existence. There are many cloud services where you upload your design file and have it shipped to you the next day. I can imagine that in the future you need a new doorknob and a new handle to your car. You just order it online and it's shipped the next day. It's printed maybe somewhere near you and brought over. So that already exists. And we also have about 22,000 printers in people's home, used mostly for education and for entertainment. So really, it all exists right now at a very, very small scale compared to conventional manufacturing, but the growth rate is tremendous. These things are growing at 25% a year in market share, so I think we'll see more and more of them.
So the people that are here today that are obviously looking at these different booths and the different providers, I mean, what do you think they're looking for?
So I think what we've tried to do in this exhibition is really to look beyond just technical questions such as what materials are available and what machines can be bought to broader implications. What are new business models that are enabled? What opportunities exist? What are the broader implications in terms of law, intellectual property, safety, certification? All these broader issues that are sort of a sign of a maturing technology that's going beyond the anecdotal application to something that's really taking off. And most people here are looking to understand that, not necessarily to buy a machine or to use it for a specific application, but really to understand where this whole thing is going. Is it for real or is it just a hype? It's for real.
Well, judging from the number of people that are here today, it seems like there's a lot of interest in it.
Yes, we've seen tremendous response, and we plan on continuing this kind of thing and broadening it.
All right, thanks, Rod.
My pleasure.